Morning, everybody. Thanks for coming. My name is Chris Bredesen. I'm an engineering manager at Red Hat, and I am principally responsible for the Red Hat Customer Portal. I'll tell you a little bit more about what that is and why it matters to the business and how that relates to me and to Solr. And I am going to talk about our adoption of Solr to replace a Google search appliance, which was our early on search solution for the customer portal when it was in its infancy, and how we adopted the Solr technology and how we brought in all of our content from the various applications to make up the customer portal. Anybody got a Google search appliance today? Any GSA customers? Got one. Okay, cool. Users of Solr or future users of Solr? Are we migrating on? Awesome. And this pre-discussion we had a minute ago led me to realize this may not, a lot of what I'm going to talk about is probably not just GSA specific. It's really migrating from anywhere onto Solr and sort of our experience in doing that. So I don't think a lot of what we'll talk about is necessarily relevant only to the Google search appliance, but some of it is. Some of the challenges we had and some of the limitations we found are sort of GSA specific. It's an appliance. I'm not a fan of agenda slides, so I just delete them. I'd like to make this interactive. I don't want to talk for 30 minutes and then have questions. I'd like you guys to raise your hand or blurt them out. I'm cool with that. I like to have interactive sessions. So we've already had a little bit of discussion already, some interesting stuff. You feel free to bring that stuff back up now that we're sort of going here. But if you have questions or want to talk about anything that relates to what I'm talking about, please feel free to raise your hand and we'll talk right. We'll just do it right in line. I kind of prefer that format. So Red Hat is the largest pure open source company in the world. We're publicly traded. We're nearing $2 billion in revenue. We're about 8,000 people. It's no longer the little Linux company that kind of was the underdog. We've kind of succeeded well in the data center, and we've expanded to lots of other sections of the market, including middleware and process management, storage, cloud solutions, infrastructure as a service, platform as a service. You may have heard of OpenShift. This is kind of our PaaS offering. We use it internally. We make money principally by subscriber revenue, right? So we make a lot of money selling open source software, which sounds kind of crazy, but that's what we do. We have a subscription program, which when you become a subscriber, entitles you to not only the Red Hat Enterprise products, but support content and other services around those products. So it's a whole package. We are extremely community focused. We recognize the value of the open source way when developing software. We catalyze communities. We participate in or sponsor or attend to dozens or hundreds of communities. Almost anything you can think of that behaves like a community, we are interested in cultivating that. I would say that, come on in. If you want to join, come on in. This is a community, right? We have potentially a community of former GSA recovering GSA users that want to adopt Solr. Solr has got a fantastic community, probably not just one. Lucidworks are great stewards of that community, of that product, of that upstream. This is something that aligns very well with Red Hat's business model. In fact, some people say we're kind of the pioneers of it. We've been very successful at it. So communities matter. They matter a lot to us. And we try to, even with our internal stuff, we try to participate in the communities that make this, that produce the software and the services that we use. I'm going to be talking today about the Red Hat Customer Portal. I manage the team of engineers that builds the Customer Portal product. And the Customer Portal is the sort of single place that you come as a subscriber of Red Hat products to interact with us. So when you want to download software, you want to open a support case, read solutions, read documentation, get diagnostics issues with your products, use some of our labs. All of this is part of the Customer Portal umbrella. And the Customer Portal is not really a single thing internally. It's a ton of applications that are stitched together with a consistent experience and consistent sign-on. But it's comprised of lots of different applications. Some of them are custom applications, some of them are CMSs, I'd say that the bulk of our content is now in the Drupal CMS, which I have a dedicated team that works on that. We, again, talking about community, we're participants in the Drupal community. We push lots of modules upstream, and we're very happy to continue doing that. But the customer portal is a combination of applications that started with sort of just a single, almost a prototype Java application, and grew into this, it kind of ate up lots of things that are related, and we use this today to present a consistent experience for our customers for anything that they want to do when as they interact with Red Hat. We've got an award every year we've applied for. Our portal's about 5 years old. We turned 5 this year. We launched at Red Hat Summit 5 years ago. And we've continued to build additional functionality. We've got expanding the team and have lots more content than we did early on. And I would say what I think makes the portal's sort of charter most relevant to this discussion is the fact that as Red Hat customers, you're entitled to premium content, right? You're entitled to subscriber content. So this is the 70 or 80,000 solutions that our support techs have curated over the course of doing their jobs. This is some of the discussion groups that are limited to relationships among your particular business verticals, that kind of thing. So the problem here is that everybody searches Google first when they try to fix a problem, and Google can't see these things because they're behind the subscription login. We get, there's teaser content, but the bulk of it is inside Red Hat's walls, so to speak. And while that sounds a bit contrary to Red Hat's open culture, when you're selling free software, there's got to be some value in the subscriber relationship that brings that benefit to you. So for us, on-site search is extremely crucial. It has to work really, really well because we don't have the luxury of having a lot of our premium content visible to Google. So it's a critical part of our infrastructure. So I mentioned before that the portal started off life as a single little application that was really literally a prototype Java application that we developed to show to our corporate leadership team. And we rolled it out, like I said, a little over 5 years ago. And at the time, it was basically the future home of what the subscriber experience would be. But it was principally a few pieces of content. How do you interact with Red Hat? What are our phone numbers? What are our support line? As well as case management. So it was the case management application. It was very narrowly focused on break, fix, support. And the last thing we wanted to do when we were trying to get this thing out the door and get visibility was to have to think about what we wanted to do. What was our search strategy? What's our metadata strategy? What's our browse experience going to look like across these different content types? Because there were essentially no content types. It was content and an app. So we had the luxury of implementing a Google search appliance that was in place already for redhat.com. And we said, well, great, you've got a couple 100,000 documents indexed there. We're going to add these results to our search results page, and it's going to make the portal look a lot bigger, a lot more valuable, because you have results from redhat.com and jboss.org and other sister web properties that were related in some way to the customer portal, but not really the customer portal. So we had a very explicit desire to increase the number of search results, right? We didn't want you to search for, rel support and get like a search result. That would look terrible. We can boost that by giving content from elsewhere. Needless to say, search wasn't a core focus of the first portal. We had a Google Search appliance doing what you would expect. It was crawling web apps, as any other customer would do. It was a straight-up crawler and providing search results through a little search app onto what was at the time the old portal look and feel, but a typical Google-style search experience. A little bit of faceting. You see down there on the lower left of that the screenshot, there's a couple of other web properties that were, Fedora, JBoss, and things like that. And from here, we were able to, include a lot of content you wouldn't otherwise see on the customer portal. It forced us to take a look at how we expose metadata on our web pages, because we wanted to allow faceting and richer drill down. So we made a lot of that happen as we brought in more and more content. It was pretty slow. The searches were fast, but the crawling was slow, but that was okay. And that's okay when you have a few hundred or a few thousand documents. As we evolved, the customer portal began to grow, and we started bringing in more and more applications. We brought in a forum feature, essentially. We called it online groups at the time. It's called discussions now. We implemented Drupal for that. And around the same time, the entire support organization adopted what's called knowledge-centered support, KCS. And this is a process by which you, as you solve support cases, you're writing a formatted document that describes the problem and the resolution. And this has lots of nuances that are far too granular to talk about here. But needless to say, a process such as that results in valuable content being produced as a byproduct of the support process becomes very search focused, right? Search becomes extremely important here. So we adopted KCS, and what that did was, in terms of the portal, it brought in what we call the knowledge base, right? So we now have a new repository of public documentation that's all published to the web, and this was our first foray into protected or subscriber content. So around this time, we started reaching the limits of what we could feasibly do with a Google Search appliance. It being a black box, it was not very tunable. We were unable to make some of the searches work the way we wanted to when it came to the documents that we were writing, the solution documents we were writing, and how their metadata was structured. Some of it was just unstructured but difficult to extract. Other stuff was varied across the org, and we were running into sort of issues there. The question of, and in today's terms, in today's DevOps terms, we have this notion of wanting to be able to bootstrap infrastructure from the ground up, Pubitize or Ansible clusters that come out of nowhere and reindex. Saw a talk last year from a gentleman who was able to build his entire Solr cluster up and reindex all of his documents in 6 hours. Fantastic, we love it. How long does it take to reindex everything in the GSA? We have no idea, we never did it, right? Nobody wanted to have to go in and reconfigure the GSA manually to start the reindexing. And furthermore, if you wanted to get a second cluster built, you had to buy another appliance, okay? So now we're running into not only functional concerns, we're running into operational and DevOps concerns. So we don't have any confidence in this thing as part of our core infrastructure, all of which is either Red Hat products or built on our team or built in open source. We have this one thing that's sort of sticking out, and it's like it's a metal box. We can't recreate it from scratch because it's too time consuming. We can't create a Puppet module that emits a Google cluster. And that's something we feel very passionate about. Everything's got to be automated. We want to be able to bootstrap infrastructure out of nowhere for any number of purposes. Functionality-wise on the portal, we started getting a lot more focus on the browse experience. So not just the search box and the search results, but the browse experience. And we began to tinker with the idea of every list page that you might encounter in the portal, we want it to be built from a search query because it's fast. We had a lot of Drupal content at this point, which was a bit slow to query and a bit slow to build pages. And so we started to dip into the idea of actually building all of our browse experience with a search query, and that was partially successful. This application you see here is what we call the ecosystem application, and this, in its current form, is a repository of all of our certified hardware, software vendors, cloud appliances, or cloud partners and things like that, that are essentially content managed documents, but are presented in a unique browse interface that is relevant to customers who want to come in and find out, does RHEL work on my HP ProLiant, whatever version 4? Or will my software run in Amazon's public cloud on RHEL? Things like that. This is our ecosystem. This is a completely search-based application and represents something that I think was about as far as we could go with the Google Search appliance without completely driving yourself nuts or hacking around crazy use cases. GSA is great at search, not so great at browse. So we had a lot of growing pains. Paying per document, okay? So GSA is a proprietary appliance. It's licensed per document. And we had, at the time, we sort of started evaluating, is this the way we want to go? We do want to look at Solr. We had around 150,000 documents, but we knew that what we wanted to do was integrate our support ticketing system into the search index, both for diagnostic purposes and for browse purposes. So we have about 1 million cases, 1 million to 1.1 million cases, and about 10 to 12 million case comments, and each one of those is its own document. So we were staring down the prospect of going from 150 to 200,000 documents to well over 10 million. And when you're talking about licensing costs, this is just not even viable. You can't even really consider it. So that was kind of the big driver of change, was there's just no way we can do this kind of volume or this kind of size of index in a Google search appliance. We had our metrics. So the principal key performance indicator, KPI, that we use for search is click-through rate. So what percentage of the time do users look at the search results and then continue on to actually view a document? Very easy to calculate metric, very basic, but it's a nice proxy for generally how is search doing, how are we doing. I mean, we would float with the GSA, we would float around 25 to 30% click-through rate. Not great. I have a full-time search engineer, SEO guru, who's fantastic, and he was constantly bothering us about this. This is not good, guys. We have to get this up. We don't know what knobs to turn or what levers to pull on the GSA to make this happen. We can do some basic stuff. We know which searches are coming back with no results. We know when people aren't clicking. We don't know how to get relevancy to where we want it, okay? Just brick wall almost. So clearly we prefer open source at Red Hat. We'd much rather be on an open solution than a proprietary appliance. So we started discussing options, and Solr was kind of the obvious choice, because in parallel to a lot of what I have been describing, we had another team working on a diagnostic tool chain whose charter was, if you can describe a problem with your system, with your Red Hat system, we will intelligently get you the right solution for it, right, out of our knowledge base. And this particular system began its life as a Lucene project embedded into our API. And was very, I call this the very narrow but very deep use case. Small document count, but extremely well tuned for a very narrow use case, which is describe a problem and give the solution. Not really a web search use case. It does not behave like Google. You would probably never drop in an entire Java stack trace. You know, if you're using a Java EE container, stack traces are like that long. You would never paste that whole thing into a Google search box, but that was the kind of thing we wanted to handle in the diagnostics engine. So we built this on Lucene. And got very good results with this. Towards the end of the, I guess I would say, implementation phase on Lucene, we were able to correctly solve your problem nearly 50% of the time in one of the top 3 results. So the way this gets implemented is this little box you see here is part of the support case screen. If you were to visit Red Hat today and try to open a support case, you would get this on the side. And what essentially happens is we post the contents of your case description back to Solr every so often and try to match the problem. And the more you type, the more you provide, the smarter it gets. 47% of the time, we get the right answer in the top 3 results. 7% of the time, people actually use it. Okay? So the system was very smart, but how to get the user to actually use it is now the challenge. So the system's smarter than the UI is. I won't say it's smarter than the user is, but it was smarter than the UI is. So this is all going along, and we had great results with this. We understood some of the nuances of Lucene and those issues, and eventually turned this into a Solr implementation because we were simply maintaining too much custom infrastructure around Lucene, right? We have an API, but we didn't want to have to build the faceting and the API and the authentication, all that stuff, as much as we had to with Lucene. So that became a Solr implementation. So as we discussed how to get rid of the GSA for the web search use case, it became obvious that we were going to use Solr. And so we took that team and said, all right, you guys are done with diagnostics. It works great. Let's do web search. And I'll talk about some of the challenges of this a little later, but that was our strategy. So search infrastructure 2.0. This is the Solr infrastructure. The recommendation engine Solr, we repurposed the same infrastructure and took that narrow and deep use case and turned it into a very broad and slightly less deep use case of web search. The principal difference here between the Solr implementation and the GSA implementation is that we're now looking at the customer portal not as a single portal and a bunch of HTML blobs. We're looking at it as discrete applications, each which have their own unique features. All these things are unique snowflakes written by different teams. They do different things, but they all have tie-ins to the customer portal. They all hopefully have consistent taxonomy and metadata, not always. So that's a challenge. But each application, and I've omitted many, there's probably about 10 to 12 applications that actually make the customer portal, the largest of which is our Drupal CMS. But each one of these applications knows best how its content behaves, meaning does content change a lot? Does it get added a lot? Is it highly structured, or is it more long-form articles, so on and so forth? So we index everything from product documentation, which is, as you would imagine, chapters in a book, to solutions, which have a very well-defined structure, to application landing pages, which have metadata like versions and things like that. And each one of these applications, it's their business to know about that, but it's not necessarily their business to emit lists and browse experience to the customer because there's just too many of them. So we carried over the indexers that we used for the Lucene project and connected them to all these new content types. And the indexing activities range from, this is sort of a dumb static repository, read it all and reindex it, to very fine-grained notifications coming from things like our CMS. I'll talk a little about the Drupal CMS because it's kind of unique how we made that work. Drupal, as if you don't know, is an open source CMS, probably one of the most widely used open source CMSs out there. It's a set of building blocks. I wouldn't call it a complete CMS because there's just too many modules and too much building to do to make Drupal a relevant website, but it's a building block. And there's at least one, if not two or more, Solr plugins for Drupal, which work fairly well out of the box if all you're doing is searching Drupal. We have today about 300,000 to 400,000 Drupal documents in there. It's product documentation and the knowledge base and discussions. The largest one being documentation, the second largest being the knowledge base solutions. Some authenticated, some not authenticated. We played around a lot with actually reading feeds from Drupal over an API. We played around with reading the database. The feeds are slow. The database is very fast, but much too low level. So Drupal is very abstract in its database structure. So when you talk about, I want to know what this document looks like with all of its metadata and its revision history, you have to rebuild the Drupal modules just to read the database in the way that you would get the content out on the web. So it was a little bit too far from reality when we go to the database directly, even though it's fast. So what we discovered was the Drupal search plugin for, the Solr search plugin for Drupal does a pretty good job of taking the Drupal content and putting it into a Solr collection. But it wasn't in the Solr collection in the way that we wanted it to be. We had at this point, a years old schema file that was highly tuned to what we wanted it to be. We have our own set of metadata schema that we didn't want to disrupt. So what we did was we said, okay, let's not try to disrupt how Drupal wants to talk to Solr. Let's let it do this. So we created a separate collection and let Drupal intelligently push content changes into that Solr index. And then we took one of our existing indexers, and instead of pointing it at a website or an API or a database, we pointed it at Solr, okay? And this worked out really, really well. The Solr to Solr was very fast. The only thing we really had to do was make sure that we were storing all the fields instead of just indexing them, but that's a minor change. And so at this point in time, we do a lot of our indexing by querying a separate Solr collection that is maintained by Drupal. So Drupal gets to do what it wants, we get to do what we want, and we have a very fast channel between them. And this has worked out pretty well. Solr even, the Drupal plugin for Solr even gives you, like buttons for reindex this content type, reindex everything, so on and so forth. And then we have additional fine-grained control over how that works when we pull from that Solr collection into our Solr collection. So we got both fast and good, which is pretty nice. It took some tinkering to get to, but this is the solution that we landed on, and it's in production today. We handle, so Solr is an API, obviously. We handle the exposure of that API to our web clients via an existing Java-based REST service that we have. So it handles authentication. It handles the shutting down of most everything that we don't want to come into Solr, because Solr is something that stays behind the scenes. And so we were able to preserve the existing Solr payload and not reinvent a new data model. So the front-end developers were able to code their search interface to standard Solr, going through our API, including authentication, and get everything they need. And the first comments that we heard from the developers was, God, this is fast. This is the best thing ever, right? It's plain JSON, it's very discoverable, they loved it, and it was fast. Made the UI fast. So what you see here, and we're getting a little short on time, so I'll try to speed up, is an AngularJS front end that talks directly to a Solr payload over our existing API. Queries to Solr are 20 to 30 milliseconds. We add some overhead on top of that I wish we didn't do, but we do, and it's mainly for authentication, some things we can speed up, but everything's sub-second. Challenges. This is the fun stuff. We did a great job of making web search behave like web search was supposed to work. But as I mentioned before, we were doing knowledge-centered support for the internal text. They use search too, and we did not do sufficient user acceptance testing for them, and we broke a lot of technical tokens and technical terms that made their lives hell for quite a while. So that was looking back on it, I would have done that. I would have handled that a little bit differently. We underestimated the effort it would take to migrate our indexers to the new infrastructure, primarily because it took us a while to get to a viable solution for Drupal, but we wound up on a really great one, which is what I described before. With wider adoption of web search, including entire browser interfaces based on search, it becomes much more important that your indexes are fresh. So in just the search use case, you could type in a word or a set of terms. Rel kernel panic is our favorite one. That's our pet peeve query that you heard Grant talk about before. If someone doesn't get the solution that was updated this morning, they're probably not going to notice. But if you have a partner manager and their IBM system got certified on Rel and they published it this morning and it's not in the catalog, that's a much worse problem. So now we have a lot of pressure to make sure the indexers keep the content fresh. And the last challenge, probably the biggest one we have, and that's what's on the graph here. This is, and I'm sorry I didn't give you legends, but that graph is the Java heap usage. So the green is the actual heap usage and the purple is the max. That spike there is the go live, and we underestimated the load we were going to get in production and had to do some very fast increases of our Java heap size and tuning of the Solr cluster. We melted it a couple times early on and had some short outages. We had another similar interesting experience when Rel 7.1 launched, along with our support for Docker, and our Docker UI is built completely on Solr. So everybody jumped in and searched for Docker containers, and every list was a query to Solr, and there was another spike later on after that, but we pulled out of that. So mind your Java clusters. They're Java apps like everything else, and you can very easily melt a Java cluster with substantial load. Results. This is my favorite slide. We doubled our click-through rate, okay? The week after we went live with Solr, my search guru said to me, our click-through rate is spiked up. It's really high. I'm pretty sure it's right, but I don't want to say anything yet because it might not be right. And so we went week after week after week, and it stayed high. So we have since, you see a dip down there, so that's literally, that in February there is the Solr release. We had an incredible increase in usability of the search engine. We have tinkered with some metrics that you see have brought it back down, and that's not anything organic. That's how we've counted search metrics, but you can see based on the general guidance, we're sustaining roughly double click-through rate on Solr versus the GSA, which is something I did not expect. My hope was we'd be where we were, and over time we'd tune it to go up and up and up. We got double click-through rate literally on day one, and we were just extremely happy about this. Consistently sub-second query response times, including our auth layer. We can do much better there, but generally the front-end developers are happy with sub-second response. So it's not something we're investing heavily in. And the developers love working with it. They're able to build, they're able to build applications that are responsive, that are tailored to their needs, using a consistent backend API. And in terms of future plans, we've talked about, and for the folks who didn't hear our little discussion to begin with, we're on an older version of Lucidworks Search. It's Solr 4.10. We are in the middle of adopting Fusion now to look at how we can replace some of our indexing logic with Fusion pipelines. And mainly, we want to use the Signals API to collect behavioral data to automatically tune the indexes as the portal is being used. That's probably the number one thing that we want. GSA does this to some extent, but we've still doubled our click-through rate without it, which is pretty astounding. I expect really great results from our integration of the Signals API to tune the indexes. We're also looking at building some better admin tooling for the SEO folks, the business admins who want to add additional keywords and do things like that. Cool. There were no questions during. Anybody have questions after that? Sir? I believe it's 4.10 today in production. Yeah. And there is an issue. One of the things that we did was we do more like this queries on various parts of the portal to experiment with driving sort of deeper engagement. Somewhere around 4.6, 4.8, more like this broke for our use case. And it's fixed in Solr 5. And so we are speeding towards a Fusion 2.1 / Solr 5 implementation that has working more like this, because the content managers are extremely interested in getting that back onto the website, because it's a huge thing for us, right? You know, we have high value content. We want people to find what they're looking for, and so we want to experiment. We want to run some A/B tests between, you know, how do we get folks to look around the portal and consume what they're looking for, versus just coming in from Google and then stopping, or just opening a case and stopping. Yep. Good, very good question. I didn't go into that very much. What kind of data sources are we indexing? We do have Salesforce. So our ticketing system is Salesforce, and when I talk about 1 million cases and 10 million comments, that's all in Salesforce. We index it today over a custom API to a custom web service in Salesforce. We don't have any out-of-the-box connector. We're going to be looking at that. We're also looking at outbound messaging in Salesforce for real time. So our support case interface today, that team would like to build that UI completely on search on Solr and not touch Salesforce until you actually drill into a support case, which means that when you post a new comment to a support case and return to the list, that index needs to be literally real time, and that's a huge challenge for us, okay? So Salesforce, Drupal, multiple web connectors that are just HTTP reads. We have, in our security section, we have a CVE database, which is the MITRE CVE database. It's how we catalog security vulnerabilities. That's a custom app written by a different team. In that particular case, there's almost no intelligence in it. We have to read the entire wad of XML every time and rebuild it. Luckily, it's a single file. It's very fast, but as that content source grows, it'll become less viable. That's going to move into Drupal. We have file system data, but it's abstracted in a SQLite dump that we read via XML. So yes and no, but we don't index files directly. We're trying to understand that too. And we're very confident that we can find data connectors, fusion connectors for some of our data sources. We're not confident they're going to do necessarily what we want out of the box, like for example, the Salesforce connector. Is it going to do everything that we want in the granularity that we want? That's something we're actually exploring now. So we don't know the answer to that. It looks really promising, but we're not completely sure yet. We're not migrating blindly to Fusion. We're bringing Fusion in simply to get the latest version of the supported infrastructure from Lucidworks. We are customers of Lucidworks. We consume the supported stack. So we want all of that. We want Solr 5 and we want the supported version. But we do see some opportunities for Fusion in our enterprise as a replacement for some of the little scripts that run or the indexes that are out there. That's a 5 or 6 year old Java application now. Don't really want to maintain that. We'd like to do more of that generically. How much time do we have? Okay. Okay, I think we're out of time. I'm happy to talk to you guys afterwards. Thank you for coming. I really appreciate it. Enjoy the rest of the show.